Okay, now for the really fun part, which is to do the collisions for this. We're going to create the collisions ourselves. We're going to feed them directly into the pyrosolver as efficiently as we can, meaning we're not going to use the static object stuff at all. So before we do that, let's take a look at the solver. The solver under the Advanced tab has this collisions tab also, where it says build collision mask. And if you hold your mouse over it, you'll see if this option is enabled, the solver will build the collision and collision veil fields, allowing automatic interaction between blah, 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 blah. Collision and collision veil fields. So that's the first time where you're going to see that. If we make a source, another volume source rather, just like this one here, this one will be for the collision. And this one will be like for density and veil. But looking at the collision one, we go to the top and we do the initialize collision. You'll see again, collision and collision veil. There they are again. So it's a well-established process that you can do this to skip past the static object stuff to do this. So have this go into this input, the advection one, the second one, and I'll just say input it can be the second context geometry. We don't have one yet, but we'll make one now. Let's make our collisions. The way we're going to do that this time is going to be kind of like how we talked about before with the particle simulation, where we were like, oh, you can do volume collisions if you want. The reason why we're definitely going to do it now is because, I mean, a volume simulation is a volume simulation. It uses volumes. No matter what you do, it's going to get turned into a volume anyway. So we might as well just make the volume. Now, the only difference I'm going to say here is I want to get the whole sim this time, the whole proxy thing. I don't want the proxy facade this time. This time I want the entire thing, because all of the velocities coming from all of this stuff is going to be very important for us. When we were doing the facade, we wanted to only essentially source our smoke and source our particles and all that jazz from the stuff that we're going to see. But all of the velocity from this whole building coming down is going to be important that we feel all of it. So start there. You can unpack it if you want. We actually don't really technically need to, I don't think, because once you go to VDB from polys, it's going to convert either way. Actually, we do need to unpack it because we're going to need to have the velocities again. So unpack it, velocity, compute velocity, make sure we see it. Very good. And this VDB from polygons is going to make us a nice, oh, look at that, it's looking weird. It's going to make this nice looking VDB thing here. Distance VDB, that's what we want. This is going to be the thing that it's been referring to as collision. So we have that, collision. We also, though, need a collision vel. So click on plus next to the surface attributes and then choose from here. It'll populate this list automatically from the attributes that it finds here. So choose here point.v. And there it is. It's on top of it. And so now we have this V thing. I'm going to go ahead and call it collision vel here, even though, technically speaking, if we look back into our simulation, this is saying source volume is called V, and then add it to the collision vel in the sim. I'm going to say, let's always just call it collision vel to keep everything nice and consistent. So collision vel. And that's what we have now here. Collision and collision vel. So let's take a look at these a little bit. If I go here, I can isolate just the surface one. There you go. Looks good. And I can do the same for the collision vel. And it's one of these situations where if I take our volume slice and volume trail, it's the same thing. It's a velocity field. I can just look at it. So here's a cross section of the velocity that's is going to be added to the simulation from the colliders. It's probably disappeared over here because the slice is just not in the intersecting it where there is something. Yeah. In any case, it's what you're used to at this point. The difference is, why is a collision vel and not just a regular collision thing? Because the way the collision detection works in Pyro is it's going to say, don't just add velocity everywhere. Add velocity right where the collision is happening. So basically things that are near the surface, I don't know why it's looking like that. Things that are near the surface of this volume, of the sine distance function, collision volume, only there, basically it's like a mask, only there is it going to add in this collision. The collider volume itself is a hard barrier that, when we talked about the pressure projection a long time ago in the earlier volumes lessons, where basically it takes the velocity field of the sim and resolves it in a way that the velocities flow around solid objects like the ground or a pig head. That's what this is. It's saying, hey, these things are in the way. Velocities are going to need to flow around this. So this will affect the velocity field itself, even though it's not adding its own velocity in. But these two working together will say, this is a thing that needs to be flowed around, and this is some extra velocity that it's adding into the sim. So there you go. As for the size of it, we can just have it be the simulation size itself, which I believe is actually already 0.1, but let's just go get it. I have a feeling Houdini is going to crash soon. Once I see the viewport behaving strangely, I get that was going to happen. I'll save it. But at any rate, there they are. I'll put a null here for organization. I'll say colliding vols, and that can go into the second input here, because that's what we told it to do. That's what we told it to expect it. Sweet. So let's see that in action now. We jump in here, press play. Oh, we won't really be able to tell at first. What you can do is go to the object itself. If you scroll down, we've got our guides and whatnot. So we can go to collision. But therein lies the rub. Where is it? We should see it. It's not there because by default, this doesn't work. By default, the solver is expecting to create its own collision vel. Remember that before from this? This is saying build the collision mask. That's what these volumes are called together, is the collision mask. So, as you might imagine, don't build the collision mask. We already did it. Now, if you press play after the first frame or so, you'll see, there it is. This is the volumetric representation of the volume we ourselves already made. But this is what it looks like in the solver. This is the most important thing. Doesn't matter what it looked like out here when we made it. Doesn't matter what you want it to look like. All that matters is what the solver thinks it looks like, and that's what this is. In that way, when we sourced it in, we didn't tell it to enlarge fields to contain sources. We don't want it to, because if we did, it would enlarge it to be the entire building. And we don't need it to be the entire building. And not yet, anyway. Currently, the solver is only here, so the collisions up here don't matter as much. Now, technically speaking, they might matter to you. We talked about this, actually, when we were talking about the difference between the old, or we'll call it Pyro Classic, and Pyro Sparse, which is those velocities that we would be adding normally, they should be getting added up here and out here, because the building is collapsing all over the place. In our case, this is probably right enough, because we're already spawning particles and smoke in the areas that are moving and falling. So most likely this is going to be virtually the same as if we were spawning collision velocity everywhere else. But that's the difference, is that in some situations you might have colliders moving somewhere else and they're not adding their velocity in because the sparse is keeping it as close as it can to the active regions. So there you go. So that's what that looks like. We don't need really to see the collider on anymore, and we won't see it anyway when we're out here. So I'm going to save it, and let's see. I guess we should cache it. Let's do that, or let's do that in the next chapter. I'll run a few frames from now, though, just to see what it looks like. So this is what we got so far. It's you can see the velocities are moving around. Because of the collision vel of the building collapsing. We can even see the particles and stuff splashing against the insides of the building because I forgot to turn the building background on. I would say one major takeaway for me, though, is that there's probably too much smoke. I think, I mean, we would see less of it certainly with the building on, but even still, I'm going to make the particle radiuses smaller. That's going to be, I think it should be tighter to the particles itself. There's too much showing up. So I'm going to press escape. Hopefully it listens to me. Come back to this here. So I'm going to say particle scale is going to be half of that. I guess we should see that change in action. If we go back to 0.1, so it looked like this. So you can see there's a lot more of it. So now the particles themselves that are creating the density are half the size. And if we're not already doing it, we should copy that over to here. I want the velocities to be in line with that. Great. So that looks good. Now it's I'm going to cache out a bunch of these things and then make a flip book. You don't have to cache them out yet if you don't want. Actually, I guess I haven't even set up the cache yet. So let's just do that real quick. I'm going to go over to the particle area, grab this, come back to the smoke, put it here. Again, all we need to do is just say smoke, and then it'll point to a different location because of this. Now I'm going to cache this out. These files might be quite large. The next chapter, we're going to talk about how to make them much, much, much smaller. But I suppose to illustrate how much smaller they can get, I'm going to cache them all out now, and so you can see how big they are. But again, you don't need to do it. So here we go.